Right class, next topic is about improper integrals. Okay, so let's say we have integral 1 to infinity 1 over x dx. Okay, so this is improper integral. How do you want to know if this is improper integral or not? When we found this infinity, okay, whether infinity or 0, okay, it is at the lower or upper limit. Okay, we can identify this improper integral when we have a 0 or infinity value either at the lower or upper limit. Okay, you faham now? So this is improper integral because we have a limit, we have an infinity at the upper limit. Okay, so how to evaluate this integral? Okay, we need to evaluate this integral to identify if this integral it is convergent or divergent. Convergent or divergent. Okay, by evaluating this integral, we can identify whether this integral is whether it is convergent or divergent. Okay, when we solve this one, if we get a limit exists, okay, it means when we get a value, a single number, we call as convergent. But if we get an infinity, okay, when we get an infinity value, we call as divergent. Okay, so how to evaluate this integral? Okay, because of this is infinity, okay, at the upper limit, so we need to express it, okay, express it in limit as t approaching to infinity. Okay, because of this is infinity at the upper limit, okay, either one, whether upper limit or lower limit, so we need to express in limits as t approaching to infinity. Then integrate 1 to t. Okay, gantikan infinity ni into t. Okay, and then integral of 1 over x dx. Okay, and then integrate. Okay, integrate as usual. Okay, integrate 1 over x. How do we get? It is ln x. Okay, you need to remember. Okay, 1 over x, it is integrate 1 over x ln x. Okay, and then the lower and upper limit here. Okay, so we know that this is a. Okay, lower limit it is a, upper limit it is b. Okay, and then how to solve this one? Okay, definite integral fb minus fa. So we need to substitute this upper and lower limit into x. Okay, limit t approaching to infinity ln t minus 1 substitute into x, it is ln 1. Okay, and then limit t approaching to infinity ln t minus limit t approaching to infinity ln 1. We know that ln 1, okay, kalau awak tekan calculator, ln 1 it is 0. Okay, it is 0 value. Okay, then we can do a direct substitution here. Okay, substitute infinity into this t. So limit, no need to write limit, sorry, I need to write limit. See, that means it is ln infinity. So ln infinity, it is infinity. So because of we don't have a single value, okay, we get infinity here. So we can say that this is divergent. Okay, this is divergent. Okay, boleh faham tak? To identify whether this integral is convergent or divergent. So this is the concept here. Okay, I give you another example. Okay, let's say we have integral 1 to infinity 1 over x squared dx. Okay, then we need to express, because of this infinity at the upper limit, so we need to express in limit as t approaching to infinity. Okay, integral of 1 to t 1 over x squared dx. Okay, and then integrate, okay, limit t approach to infinity 1 to t. Okay, 1 over x square, how to integrate this one? Okay, we need to move to the top. Okay, x square move to the top, it will become x negative 2 dx. Then we can integrate. Okay, so integrate x negative 2, it will become x negative 1 divided by negative 1. And then limit lower and upper limit here. Okay, nampak tak? And then substitute. Okay, limit t approaching to infinity. Okay, this one is negative here. Okay, that means it will become negative x power negative 1. Okay, move at the bottom, move to the bottom, will become 1 over x. Okay, negative, stay negative. Okay, and then x power negative 1, okay, jadikan dia positif. Okay, positive value. Okay, so move to the bottom, it will become 1 over x here. Okay, and then substitute. Okay, substitute t into x, negative 1 over t minus negative 1 over 1. Okay, so negative 1, negative, it will be, it is positive. T, okay, negative 1 over t plus 1. Okay, and then, so this is fixed number, right? So limit, okay, limit t approaching to infinity negative 1 over t plus 1. Okay, that means awak kena expandkan dia macam ni. Okay, because of this is fixed number, so you need to write limit again. Okay, you need to write limit again, and then substitute infinity into this t. So it will become negative 1 over infinity plus 1. Okay, so 1 over infinity, it is 0 value, plus 1. So the answer is 1. And then this value, it is, that means it limit exists. Okay, that means limit exists. So we can say that this is convergent. Okay, this is convergent because limit exists. We have a single number here. Okay, so let me explain about P series. Okay, P series. Let me explain about P series. Okay, Okay, the general form of P series, integral of 1 to infinity 1 over x power P dx. Okay, if P more than 1, okay, this P, okay, if P more than 1, we can say that it is convergent. Okay, if P less than or equal to 1, we can say that it is divergent. Okay, so kita recall balik. Okay, recall balik. Okay, yang tadi saya dah explain tu. Integral of 1 to infinity 1 over x dx. We get infinity, right? So we can see that this is divergent. So we can check 1 over x. Okay, x, this is power 1. Okay, so kalau kita refer pada P ni, okay, 1 ni, P ni, 1 ni adalah P dia. Okay, 1 ni adalah P dia. So if P less than or equal to 1, we can say that this is divergent. Okay, so kalau kita dah solve tadi, kita dapat infinity. Yes, it is divergent. Okay, kita boleh check based on of P series here. Okay, when x power of 1. Okay, so P, it is less, if P less than or equal to 1, it is divergent. Okay, second example, integral of 1 to infinity 1 over x square dx. We get what? We get the value 1. And then we can say that this is convergent. So kalau kita tengok pada P ni, P is 2, right? So if P more than 1, it is convergent. Okay, so kita boleh determine this integral by using the P series here. Okay, if P more than 1, it is convergent. If P less than or equal to 1, it is divergent. Okay, dah faham nah?